Okay, so we talked about the amphibians in the first part of this lecture. Now let's go into the reptiles. But what I want you to think about is if you had an amphibian, you have some ancestral amphibian, and you think about the basic general amphibian body plan here, what would you tweak and adjust in order to enable it to live completely on land? So let's move away from the water. Let's access new habitats. Let's access new environments. This is an amphibian. What do I need to change on that to say, okay, you don't have to still be tied to the water. You can move 100 miles away from that river and still live and function and survive as a new group of vertebrates. So that's where the reptiles come into the picture. Reptiles are basically improvements upon the amphibian features. Right? That's what it really is. It's not a new thing. It's let's take existing and let's tweak it to make it a little bit better. So you guys all have a smartphone. In 6 months to a year, you're going to ditch that one and trade it in for a newer model. What's different about the newer model? Just a few things. It's not reinventing the wheel. It's not a brand new phone. It's just a phone that has a couple features that have been tweaked to make it a little bit better. So the key 3 features that changed, that evolved, that modified from amphibians to reptiles are the legs, lungs, and the skin. So I want you to think about that. Let me clear some space here. So the legs, stronger, more durable, and when you get this bigger, stronger legs, it actually increases the chest capacity or the chest cavity. So that means if you change the shape of your chest, now there's more space in there. Increasing the chest space changes the lungs. So now you can breathe better. You can bring in more oxygen through your lungs because they're bigger, they're stronger, they're more efficient. And then the skin will dry out, which means you're decreasing the water loss through the skin. So huge adaptations that made them successful. One other big thing to mention is we see this in reptiles and not amphibians, is a thing called the amniotic egg. This shell around the egg, this amniotic fluid or amniotic structure, helps support and protect and nourish that embryo, and it decreases water loss when we're looking at the egg. So you don't have to have water there to breathe, and you don't have to have water there for reproduction. Amphibians lay their eggs in moist, wet, aquatic environments. Reptiles, they can drop them in the desert. Turtle comes up onto the beach and lays its eggs in the sand, and the shell of that egg protects it and allows that embryo to survive or increases the survival chances of that embryo. Okay, so big key features, big things that we want to identify with reptiles that make reptiles different from the amphibians. Now, just a brief evolutionary history. Reptiles, the earliest ancestors of the modern reptiles are these things called synapsids. They evolved roughly 300 million years ago. And the way we identify a synapsid is we look at the skull, and there is a hole behind the eyes. There's this thing called the synapsid arch, and there's a hole back here. There's also a bunch of muscles associated with the jaw structure here. So these guys are pretty powerful predators. They can chew, rip, tear. They have enough of the features that enable them to be a pretty functional predator. So they did well. They were around for quite a while. A little bit later in evolution, we get a branch shooting off from the reptilian ancestor called Therapsids. These are about 280 million years ago. And these guys are kind of like mammals. They're not mammals, but they're kind of like, or we say mammal-like, when we look at this group. The two big things that kind of connect them to mammals is the fact that they were endothermic and that they had hair. And those are some important mammal features. Again, Therapsids are not mammals. They're a mammal-like reptile, kind of a in-between group. And then we can also see another group called the Diapsids showing up. So you got all three of these groups roughly around the same time, competing, trying to find resources, who's going to be most successful, who's going to adapt and evolve, and so on and so forth, and who's going to go extinct. The Diapsids, the identifying feature are these two holes behind the eye socket. Again, the Synapsids had one. These guys have two holes over here. Okay, so we got all this reptile diversity happening 300, 280, 250, etc., millions of years ago, and it explodes. It's what we call the age of the reptiles. They're doing great. The Earth is a perfect environment for them, and they're doing just really, really well. From the Diapsids, though, is probably the more well-known reptiles. And this is where we get this group from the Diapsids. We get this group showing up called the Archosaurs. And then from the Archosaurs, we see this group giving rise to things like crocodiles, the dinosaurs. From the dinosaurs, we get all sorts of diversity. The earliest ancestral birds, and then eventually modern birds evolved from the ancestral birds that evolved from the dinosaur groups, from the Archosaurs, and so on and so on. So reptiles in general have been phenomenally successful when we talk about their evolutionary history. I'm sorry. They've just done great. So our focus right now, though, is modern reptiles. Let's go out and try to find these guys. Let's take a walk. Let's see what we can find. What do we see for traits with modern reptiles? All right. So most modern reptiles have a or four-chambered heart. So amphibians have a three-chambered, fish have a two-chambered. So notice the trend in the heart. As your heart changes, your circulatory system changes, your gas exchange efficiency changes, etc. Keep following that pattern. In general, modern reptiles are all ectothermic, meaning cold-blooded. So it's 38 degrees today. No, you're not going to see a lot of reptiles out. Wait a couple days, and when it goes back to 70 degrees or 80 degrees in the spring here, that's when your reptiles start getting active. So they're ectothermic. And modern reptiles use internal fertilization. So now egg and sperm combine inside the female, creates the embryo. She forms a shell around it. She lays the eggs. Typically they leave. Frogs, amphibians, most of them, external fertilization. Squirt the eggs into the water, squirt the sperm on top of it, let it go. Hopefully it works. Okay, again, there's always exceptions that don't fit the general rule. I want you guys to be comfortable with the big general rule of these groups. So, okay, what's out there living today? Chelonia. This is a group of reptiles. Turtles, in tortoises. Those are the Chelonia. Typically, the body is encased in a shell. We see our sea turtle, our Galapagos tortoise. They have a shell protecting the body. The vertebrae and the ribs are actually fused into the shell. So you cannot remove the shell from a turtle without killing the turtle because the vertebrae fused into it, and so do the ribs. Lots of characteristics. We see them across different habitats, from terrestrial to aquatic, freshwater, marine, etc. But they're reptiles. Rhynchocephalia, weird group. These are known as the Tuataras. There's only 1 or 2 species, depending upon which source you're using, that are identified under this particular grouping. Big key feature with the Tuataras, they have this, what they call the third eye on their forehead. It's a light sensing structure that enables them to detect shadows. Most reptiles are active during the day because it's warmer in temperate environments. So in Illinois, you don't find a lot of reptile activity at night. You find it during the day because it's warmer, and again, these guys are ectothermic. Tuataras, though, are active at night. Their metabolism's a little bit different, and they can be functional at night. The group that we're probably more familiar with are the Squamata. Now, Squamata include the lizards and the snakes. So these are reptiles that are active predators in general, improved jaw structure. It just depends. Iguanas, when they're adults, they're eating vegetation. When they're younger, they're eating insects. They're little carnivores. Snakes, by and large, they're all carnivores their whole life cycle. Snakes are just reptiles that have lost the legs through the evolutionary process because of the ecological niche that they've evolved into. Crazy as it is, we do see snakes occasionally that have hip bone structures, usually your boa constrictors, some of the larger snakes like that. Sometimes the hips are there. It shows that their ancestors at one point had 4 legs. But generally, just active predators with these guys. Most of the lizards obviously have 4 legs. Snakes lack the legs. And then the last group to mention of reptiles are the Crocodylia. And within the Crocodylia, we have the crocodiles and the alligators. All right, so we could also have the caiman, the gavels, but in general, crocodiles and alligators will be under Crocodylia. Primarily aquatic, these guys are all straight up predators. Look at the mouth, look at the tooth structure, look at the evolutionary adaptations. You got active predators here. What is a little different, this group is one of the few reptiles that will actually take care of their young and show a lot of parental care. Parent crocodiles and alligators mamas will nest. They'll protect the nest, they'll guard the nest, and when the babies are born, they'll keep an eye on them. Most of the other reptiles drop them and go. Those sea turtles that everybody loves. Mom comes to the beach, she lays her eggs, she swims away and never looks back. Those eggs hatch out, who knows what's going to happen to those babies. Zero parental care. So we see some variations, obviously, within every group with how these things have evolved structurally, behaviorally, and so on. So that wraps up Amphibian and Reptilia. Just broad overview. What I will continue to try to stress, this is just kind of the highlight reel about biodiversity. You guys like this stuff? Take a full course in herpetology where you spend a whole semester studying just amphibians and reptiles. Take a whole course in fish. Take a whole semester in each of these areas that you find most interesting. That's what you do as you move on up to your upper level courses. This is just, again, our big buffet survey of diversity.